Assalamu alaikum everyone. So today I'm going to talk about the mass spectrometry, and in this I'll be talking about the rule of 13. So in mass spectrometric analysis, this is one of the important rules in order to determine the molecular structure or the molecular formula of the organic compound. So there are certain steps involved in determining the molecular structure through this rule. So the first step is that okay, so we know that in the mass spectrum, the analysis that we perform, so we are given a certain peak of m plus. What is m plus? M plus is basically the first peak that is given to us by the mass spectrum. That is the parent peak, that is actually the gives the molecular mass of the compound. All right, so that peak is basically the first peak given to us by the mass spectrum as m plus, and this is the basically at 15 electron volts, and when we increase the voltage to up to 17 electron volt, we get the fragmentation patterns and the different radical cations, etc. So I'll not go into detail, but here we only focusing on the rule of 30. So as it is illustrated in this slide, that the first step in determining this rule of 13 is that the molecular mass that we are given, the m plus peak, will there it will be a certain whole number ratio, right? It may be 30, 40, 56, 78, any number. So that will be given to us, and we'll divide that mass by 13. All right, the first step is dividing m plus by 13. That gives us the n value. What is n? N is basically the number of hydrogens and carbons. We know that CnHn plus 2 for alkenes and CnH2n for alkynes, similarly CnH2n minus 2 for alkenes and alkynes. All right, so here n is basically the number of carbon and hydrogen atoms that is same. So after getting that, we get the molecular formula of the compound. But if we get some fraction form or a decimal answer, so what we'll do is we'll follow couple of other steps to get the final answer, and if we get any sort of remainder, we'll consider them as the additional hydrogens. So the first example is a simplified example, and we'll then move on to some complicated ones for a better understanding. So the first one is m plus 78. So the first example is having m plus value of 78. So first we'll divide this by 13 and we'll get 6. So n is equals to 6, and our formula gets C6H6. So this is our formula of the organic compound. Similarly, in the second example, we have m plus of 92. So the first step will be divide this number by 13. We get 7.077. So we'll round it to 7. All right, so after getting, as we get a fraction form or decimal form, so what we'll do is, in order to be on the safe side, we'll multiply this 7 that we have rounded the n value with 13. First we divided it, but we didn't get a whole number, so we'll multiply this 13 and we'll get 91. So now we can see that there's a difference between 92 minus 91 is 1. There's a difference of 1, so this is the remainder, and this 1 will be added or considered as extra hydrogen. So the n value was 7, that was C7H7, so plus 1 will be C7H8. H8 is the one extra hydrogen that we got. Similarly, in the third example, we have m plus of 161, and 161 will be divided first by 13. We get a decimal fraction, so we'll round it to 12. So we got 12. N is equals to 12. So similarly, there is not a whole number digit, so we'll multiply it for with 13 to get to be on the safe side. So now we get the answer, that is 156. So we are m plus was 161, so it means that there's a difference of 5. So these 5 extra hydrogens, they will be considered as, so the formula will be C12H17, because 5 is the remainder, and we have understood previously that we'll consider this remainder as additional hydrogens. All right, but if we multiply okay, there will be also a thing that if even if we get a like a whole number digit, like it's 7 in the previous one, so we'll multiply with 13, we'll get 92. All right. The sorry, it is not 7, it was the rounded one. The first example, if we get 16 into 13 will be 78, because the answer digit is a whole digit, it is not a decimal form. But when we get a decimal fraction, so it is very much obvious that there might be a certain difference. So for that we just multiplied with first we divide it and then we multiplied with 13. Okay, now what about the heteroatoms? So for heteroatoms, like for any oxygen, nitrogen, fluorine, carbon, sulfur, we have to add these into the molecular formula. So for this, what we need to do is first we have to derive the formula as above, that we have discussed in the above examples. And now when we have to add any heteroatom, what we'll do is we have to subtract the equivalent mass from the formula. For example, okay, for you'll get it from this example. For example, we have m plus of 108. For the first step is that we have to divide 108 by 13, we get this digit, and we'll round it to 8.3 is the answer, so we'll round it to the nearest number, whole number ratio, whole number, so we'll get 8. All right, but if it was 8.5 or 8.6, so we'll round it to 9. We know this now. So it is 8, and 8 into 13 will be 104. So there is a difference of 4. 108 minus 104 will be 4. So there are 4 extra hydrogens in addition to 8. For example, C6H8 was our molecular formula, but there was a difference of 4. So we'll add this 4 into hydrogens, we'll get C8H12. So also, when we have to add any heteroatom apart from carbon or hydrogen, what we need to do is we have to subtract the equivalent mass from the formula. For example, if you want to add oxygen in this formula, the above one CH12, what we need to do is we need to subtract minus CH4. Why? Because the molecular mass of oxygen is 16, and how we can subtract 16 by subtracting one carbon that is having a molecular mass of 12 and 4 hydrogens that will be having 4 molecular mass. So 12 plus 4 is 16. So in order to add 16, we need to subtract 16 from this CH812. Alright, similarly, if you want to add oxygen and nitrogen in this above formula CH12, what we need to do is we need to subtract 16. Oxygen's mass is 16 and nitrogen's is 14. So how we get 14? 1 subtracting 1 carbon and 2 hydrogens. 14 and subtracting 1 carbon and 4 hydrogen, the methane molecule will get oxygen. So by subtracting these, we get 2 carbon and 6 hydrogen are subtracted from this formula, and we add oxygen and nitrogen. All right, and also there is a rule that when the so for even molecular mass we have 0 or even number of nitrogen atoms, and for odd molecular mass we have either odd or odd number of nitrogen atoms. So this is the further elaboration, but we have to discuss only rule of 13, so I hope it's clear. Thank you.